Here's problem number 11 from section 7.2. Let's start by rewriting this equation in the form x equals. And if I do that, I get x equals y squared minus 1. And then let's graph that out. So when y is 0, x is negative 1, and we have a parabola, and it opens like so. Let's do the same thing with our other equation. Let's solve it for x, and I get x is equal to 3 minus y squared, which means when y is 0, we're over here at 3, and then this parabola opens this way. Let's now figure out what the area between here. Now, in order to do that, I'm going to draw a typical rectangle, and in order to get it to go from two different curves, the orientation of that rectangle is going to be such, and then that means the height of that rectangle is going to be measured as a dy. Looks to me then like the area is going to be the integral of the larger of these two curves, the upper curve, the top curve, in this case the one that is most to the right, because the x values for that curve are larger, which is going to be our second curve. And then we're going to subtract that by the value over there, so that whenever we do those subtraction we get a positive number. And this other curve is the y squared minus 1 dy. All right. The last thing we need to know is the limits of integration. Let's take these two equations and set them equal to each other. And let's solve for y. Add y squared to both sides, and I get 2y squared. Add 1 to both sides, and I get 4, which means that 2 is equal to y squared, which means that y is equal to plus or minus the square root of 2. And so down here, y is negative root 2, and up here, up there, we get positive root 2. All right. Now let's do the process of cleaning up and integrating. The integral from negative root 2 to root 2. Let's distribute this negative sign through both of these terms. And I get a positive 1 and a positive 3 to make a positive 4. And I get a negative y squared and another negative y squared to get negative 2y squared dy. Now let's take the antiderivative of that expression, 4y minus 2/3 y cubed, and we're going to evaluate this from negative root 2 to positive root 2. From there, we're going to evaluate it at the upper bound, 4 times root 2 minus 2/3 times root 2 cubed, and here we have at the upper bound, minus 4 times negative root 2, so negative, minus 2/3 times negative root 2 cubed. Okay, let's see if we can clean this up at all. 4 root 2 from there. Here I've got 2 to the first and 3 halves. 2 to the 3 halves. So 2 to the 3 halves plus, or times 2 to the first is 2 to the 7 halves over 3. Let's clean up this a little bit by doing a little distribution. If I distribute the negative sign through these terms, I get a plus sign there and a plus sign there, but it doesn't take care of that negative sign there. So I end up here with another positive 4 root 2. And then, similar to what I have here, I'm going to end up with a negative 2 to the 7 halves over 3. Giving me 8 root 2 and just to do a little work here, 2 to the 7 halves is 2 to the 6 halves times 2 to the 1 half, or this is 2 cubed times the square root of 2, or 8 root 2. So right here I have 8 root 2 over, I have 8 root 2 over 3, and I have another subtracted 8 root 2 over 3, which means I've got a total of 16 root 2 minus, 8 root 2 minus 16 root 2 over 3. Or, if I find a common denominator, that's 24 root 2 over 3 minus 16 root 2 over 3, which gives me 8 root 2 over 3. And that's problem number 11.